expected of x conditional to expected of theta, sorry, theta given x. We write it also differently. We write it like this, theta given x. And the explicit relation is theta given x. But you can do also something else. You can take the median. How to do in general? When you have, this was molecular, this was a priori, this is a posteriori. If you have the expression of the a posteriori, you can take maximum a posteriori, you can take expected value. These notations are the same. And finally, we need a few things about decision theory. Decision theory is based on very simply, not too detailed, is that let's assume that you wanted to estimate theta. And you obtain theta hat. This is the real value of theta, and this is what you obtain. So you can define the error. Theta hat minus theta. This is the error. You would like that if you have made a decision, if the value of theta was 100 euro, and you have estimated that it is 120 or 80, you made some error. You want that this error be punished in some way. So you define a cost function. For example, you want that more the error is important, because you have made a decision, more the error is important, the cost would be more important. In general, this cost function is, in general, it is a function which increases with the error. And one of the cost function which is very usual is to choose a cost function which goes positively. So one of the cost functions which is positively and what you would like is that you decide that the best decision is the one who minimizes the average value of the cost function. So you define argument which minimizes the average value of this cost function. Average means expected value. This small is expected value. Is expected value of CR. And what is interesting is that you can choose different cost functions. One of the cost functions is the qualitative one. Somebody else says that no, this is too too much, because it goes up too much. The punishment is too much. There are some other cost functions has been used, which is, for example, goes linearly, and some other cost function which says that, okay, if you make an error, a small error, or if like this. All of these are the different cost functions that have been used in practice. If you use quadratic cost function, this is quadratic. This is absolute value, and this is 0 or 1. 0 is delta theta is in absolute value less than some epsilon, and 0x. Quadratic, absolute, and this delta function or inverse delta function. What is interesting is that if you choose this cost function, compute its expected value. Do it as an exercise. You choose this cost function, compute expected value, and then minimize it, and you will obtain, for this case, case 1, 2, 3. For case 1, you will find that the result is this. For the case 2, you find that theta hat will be median of the posterior probability. Do you know what is the median? Not expected value, but median of theta median. Let me remember you the median. If you have a probability distribution, let me plot something which is not symmetric, if not median and not all the same. Let's take the example of gamma distribution, which is not symmetric. If you have this distribution, this is mode. Mode is the value of x which maximizes. This is mode. Expected value may be somewhere here. This is expected value. How it is computed, this expected value? This mode is argument which maximizes here. Expected value is integral of x, p of x dx. And the median may be somewhere here. Median is a place where the surface here is equivalent of the surface here. Median of x is such that integral from minus infinity to that median is equal to integral of median of x Okay? The probability that the values of x be superior of median is the same as the probability of x be less than median. If a probability distribution is symmetric, all of these three are the same. Okay? If the probability distribution is symmetric, this, and this will be the same. But if it is not symmetric, they may be different, and the significance are different. So here, you will have expected value, here you have median, and for the third case, it is easy to show that for the third case, we have the mode or what we call theta hat map. Okay. Now, the main questions. I'm going to write again the bedroom. One of the questions that arise in parameter estimation is, remember that what we did. We first assume to know this expression, but not know theta. This was maximum likelihood. And we assume that they are independent. Then, in the Bayesian approach, we assume that we know a little more also about the parameters. And knowing a little more, we translate it by prior probability. No, the question is, that's fine, it's prior. How to choose P of theta? And this is one of the great questions and great critiques that many mathematicians was doing for the Bayesian. How you do to assign a prior? And the answer to this question was a debate for about more than 20 years. Nowadays, everything is smooth, but still there are fight between Bayesian and non-Bayesian. And it was about more than 20 years that in many conferences there has been many debate about how to choose a prior. Here I am not going to revive this debate, but just give you some of the propositions that has been done. And for this, let me ask a question which is more general than this, which is how to assign a probability distribution to a quantity. And actually, we are going to request again. The question is that I have an unknown quantity, x, and I want to reattribute, assign to him a probability distribution. So the question that, a more general question that here is how to assign if you answer to this, then we can go back to this part. A pair is one of them. How to assign a probability distribution or a probability load to a quantity, to an unknown quantity. If X is an unknown quantity, for example, if I asked you what is the difference of volts, the difference of potential electrics between the two plugs of this electric system. This is the question. You are not sure. You are going to do some observation. You are going to take a voltmeter and you are going to make observation and decide for that. But before, even before trying to put your instrument and measure it, you think a little, okay, I am in China or I am in Canada. If you are, or I am in Europe, in why I mentioned Canada or United States and other countries, because in some of the countries you know that the value is 110. In some other countries this is 220 or 230, 240. So even when you are going to take a voltmeter and you have to select the scale. So if you are in Canada, you put maximum 200. If you are in Europe, you put it maximum to 300. And then you make the measurement. So before doing the measurement, you knew something. You was thinking about something. And this thinking was giving you the possibility to change the scale. So we never do the things with ignorance. If you do something with absolute ignorance, it means that probably you will do it badly. Because if you take the voltmeter and it was not on 200 or on 300, and if it has been put on 100, and then the potential is 220, it goes very fast and it should destroy the instrument. So we know something about it. The question is that is something that we know is very, very general, very macroscopic. And how to define this macroscopic and very general things is that very often you may know the word expected value is exactly this. You know that the expected value of X, you may know it. This is 110 or 220. Okay. So, and you may also sometimes know something else. For example, if you are in France, you know that in France the electricity is produced by Electricity of France, VTS, and you are confident to the electrical installation, and you say that, okay, if I know that it may not be, it may be around 220, but it may changes around this, not more than 5. So it means that you know also something about the variation. So you may know the variations around this element. So this is 220, and this is what we say plus and minus something. Standard deviation. Okay. So, no. Just that, assume that that is the only things that you may know. And now the question is, what is the probability distribution? This is an ambiguous problem. You may define many this probability distribution where the mean value is m and the variance is e. There are a lot of them. So the problem is solved because you can choose many probability distribution which satisfies these two conditions. So problem is because there are many solutions. So what to do? We had principle of maximum likelihood, and here I am going to talk about principle of maximum entropy. But probably you do not know a lot about entropy. So I have to introduce what is entropy, and then we are going to use it for answering this question. So let's talk very shortly about entropy. You see that we open a parenthesis. Inside this parenthesis, we are obliged to open another parenthesis, and again another parenthesis. But this is the way to understand the main ideas of Bayesian. And the next time, tomorrow, we are going to use these tools for real inverse problems. But these are very important to understand very well the basics of physics. So what is entropy? You know that you have heard about Shannon. And probably some other names is James. Later, many times later. But, these are two names which are important in this definition of the entropy. And the main idea actually goes back to the history, probably old Chinese or old Persian civilization. Says that if a quantity takes the values of x1, x2, x3, x4, and xk, with the probabilities p1, p2, p3, pk. The first question is how you can define a quantity of information. What is an information? If I tell you that the sun rises every morning, you know that it's normal. There is not really any information to that. Because the probability that the sun rises every morning is what? Something which is certain doesn't bring any information. But if I tell you that this afternoon we will have sunshine, knowing that it is raining, this makes, if really I know that I bring this information, that is more important because the probability is less.